So this is our, I'll say, fifth or sixth, I think sixth boot camp. So the reason, and one of the reasons why we have this boot camp is, you can hear from the mic?
Yeah.
Hello? Yeah. So one of the reasons why we have this boot camp is, see, generally when I was working for a company called Pitian, we have all sorts of events so though I was based out of Chennai, we have all sorts of events in Canada where we have virtual events, and we have lots of technology learning sessions. There are not so many events that happen in India, especially for people to actually share technical knowledge and learning. And if so, there are something, they are mostly in Bangalore or some parts in Hyderabad, so there's not much in Chennai. So since I'm based of Chennai, so I thought I would start this event in some way in my capacity, that people here can actually engage and learn. So this helps in a couple of ways where where people can actually start learning, sharing, and you can get like-minded people get together and start working on this. So about me, I am Abhilash. I am an Oracle Ace Pro. So I am the founder of Nabhaas, and a lot of my team is available here. So we completely manage, or we are experts in Oracle databases, Oracle Cloud, and Oracle EBS, and anything on the Oracle database stack. We have the services. So we are kind of all our team. We live and breathe Oracle. So what we can do now is we will get to know a lot of new technology areas to understand where we are currently, what is how the Oracle Cloud scope is going, and we will focus on certain areas in Oracle Cloud, and we will understand certain utilities in Oracle Linux. We will understand something about databases, etc. So that in a technology area, mostly people who are techies, or who are either developers or SREs or DBS. If a technology has 100 areas of work, you probably will work on a day-to-day basis of only about 20 to 30% of that stack. See, so the remaining 70% is just mostly know-how, or you are aware of it, or you don't know. You may not have ventured into it because you may not have the opportunity to work on it. So the thing about consulting is, you really need to be aware of all the things that is happening about, and then when the situation comes, you need to apply your learning into it. It's just like a good doctor. A doctor knows a lot of things, but when the patient comes up with the required illness, they will apply their mind, their learning to identify the correct source. You don't have ready-made prescriptions for ready-made side effects, etc. It's the same thing with consulting as well. So you have to first understand what technology is providing, why the technology is available. So a lot of things that actually start from actually looking technology as a technology. You cannot, see whether you should first understand why it exists. So if Oracle as a technology, or even SQL Server, or Microsoft, or Sybase or Postgres, any database that you take, you should first understand why such a thing exists, and you should apply this to any technology that comes up. So because there is a requirement for that, something has been developed there, and you'll have to start working, and someone has developed something and someone is applying something, and that is why a lot of market is coming up, and that is why a lot of work is coming up, and that is why people are learning to understand this new things, etc. So now coming back to the topic of what we are going to do is, we are going to focus on what Oracle Linux is about. We are going to focus a lot on Oracle Cloud. So we will have an Oracle speaker who will be coming and understanding about the full stack. He will be coming a little late, but he will be presenting after some time. So I'd like to give you a walkthrough of what Oracle Cloud, etc. So we will have a market board. So after some time, we'll just turn around and I'll explain you. I'll walk you through everything that is there currently and what is actually happening, and I'll have a presentation of it, and I have a small lab session of how of how do you troubleshoot how do you troubleshoot when a certain activity happens, etc. So when this happens, you would naturally think to relate to your work what is how you need to apply, etc. So let me just begin about myself. Now, this is a brief introduction. Like I said, we have 3 sessions today. One is about Oracle Linux utilities, and before that I'll explain the history of Linux, where it started, etc. And then about OCI databases, and then we'll have a third session from Suraj Ramesh who will be coming through this. Now, this boot camp I chose specifically this event and this time because Saturday evenings mostly people are very comfortable with with attending these events, and then Besant Nagar is a very comfortable area for everyone to attend, and it's just not me alone. If there anyone who wants to share their knowledge on this, you can use this platform to actually understand about this. So then, so like I said, I'm an Oracle Ace Pro. I'm the founder of Nabhaas. I have expertise on Oracle Linux, etc., Google Cloud, but my hardcore experience is on Oracle Cloud, and I keep evangelizing about technologies on other databases as well. So you can reach me at LinkedIn here. I'll give you the LinkedIn portfolio. I would like to connect with everyone after this. So then, most thing about Oracle Cloud is everyone wants to understand how cloud technology is, how things work, etc. The first thing to understand about cloud technology is like you need to understand every technology that has people. First thing who do is that you do a Google search of the documentation. Now, for any techie who has to work, I would say don't do a search of any random Google search. You're going to a technology, go to the specific documentation of it and you start searching there. You will get better understanding of it. There are 2-3 reasons why I say this. Number one, you will eventually find what you are looking for. And the third point is, like I said, when you're working in a technology, you have 100 areas of technology and you work on 20 to 30% of it, and it is an opportunity for you to understand what else is there while you keep searching for that. But when you do a broad search, things you will actually find someone who has blogged something about it, someone whose experiences about how they use the technology, but very rarely you go to a product documentation and understand it. So that is the true picture of it. But the moment you understand how a documentation is written, then you start understanding the language of how the technology provider is giving the information. So that's the first thing is it's just not with any technology, right? See, you buy a product. Every product comes with a manual. You buy an iPhone, you get a manual of it. I'm sure nobody will read the manual. You put the manual in the box and you start using the phone. There are a lot of things, a lot of features in the phone that are available. You must be aware of it. The intuition to understand what is there is what makes good consulting engineers. Now, to start with, generally when people say about so now, like I said, what can SREs or DBAs or developers, what can you learn from this? So there is a wealth of information available everywhere, but you will have to know where to apply to it. And this is just not a session. This is not more of a training session for people, but it's like pointing you at here. It's like guiding you to the right path. Like you're going somewhere, then you need to understand why you're going there. And there are so many cases of things that people would like to move their applications to Oracle Cloud. There's so many challenges, like how do I start? Where do I get this information from? Where do I see, if you are let's say if you're starting, if you have an organization that's completely on data center and suddenly you want to move to the cloud based on a management and you are in the technical stack there, where do you start? I mean, all these questions arise. All these arise like, what is your first place to start? So is my environment cloud ready or not? So then now you try to understand that, then typically when you go to a consulting company, they would prepare some kind of an architecture like this and say that, no, this is what you should be doing it. But you need to understand what are I would say the devil is in the details. You will have to understand what is the smallest part of each application is. So, for example, this image shows that, you can understand this image from your understanding so many things that this is a database. But do you know what this image is? Or do you know what this image is? This is a compute server. Okay, then you have a load balancer. So, which means you need to understand by looking at the diagram. There is nothing about technology or anything. You need to understand by looking at the diagram how your traffic flows from on-prem to cloud. From anywhere to the cloud architecture. So this is what I want to be. This is what I would like my infrastructure to be. So where is a good place to start? Where are things that I need to focus on, etc. So then, of all these platforms, the fundamental part of this is Linux. Okay, Linux is the de facto operating system across clouds. So I'll give a small introduction of the history of Linux and what it has happened, and why Linux has been the de facto operating system. We'll come to that. But then, the moment you understand Linux, it's like a very broad ocean. The moment you understand Linux, then all the operating systems and everything that lies above that would be much more logical to work with. So we see a lot of Java developers, we see a lot of Python developers who work on the application stack, but hardly nobody understands the operating system layer. They think that it is a system engineer's responsibility to understand the operating system layer. So Linux by default is a very strong, robust, simple language, and there is no, I would say, there's no equivalent to what Linux is. There's no parallel to it. And every cloud adopter is taking Linux and they're customizing it to themselves. Now we'll understand what are the basic things of Linux. Every operating system will have its own mount points, its own activity, its own reasons to how a Linux is. So if you have a small Linux disk, if I have one, I'll also show you how a Linux server exists in a cloud environment. So if you have one Linux server with one hard disk and one mount point, etc. So it's just like for those who are completely new to Linux, this is like when you have your laptop, you have your C or a D colon or a C colon, etc. You have various mount points. And this root is your heart of your file system. So each file system has its own understanding of it. So if you are working on Oracle, this is probably what you will be working on. The little /U01 is where your software installations are. So we'll come back to how this works, but I'll actually want to take a small history lesson on how Unix evolved before going to the clean technical details of how this is. So we'll just switch on the lights, and I request you to just turn a little bit to the marker board so that I'll understand how, I'll explain how the history of Unix, etc. So let's understand. See, I think Unix started as Unix started as a concept. It is not more of a. I'll start with this. I'm talking this about 1970s or 80s. So Unix started as a concept, and then it's like an operating system. How people would run there. That's when the computing started coming up. So Unix started as a concept where people would want to have some computing capacity to actually have some kind of a computing capacity, like to store some files, to write some files, to create some digital footprint at that time. So I think in 70s, I think the maximum size was only MB, maximum I'm saying. It was just bytes, it was bytes, kilobytes, and then MB. So you might see a lot of people, the IBM systems where for 10 MB storage, you have such a big storage systems. So that was in 70s, like that's how the computing evolved. So what happened this Unix is, people started developing this, and then this actually branched out. So this was not, I would say, open source. There's no such thing as open source at that point of time. The entire source was open. So anyone can take the source, and anyone who are trying to contribute it. Open source is very recent term, like 15, 20 years or probably 25 years ago. So the entire source was open, so people wanted to do new things on computing, etc. So Unix started as a concept, and then the first, one of the first companies to actually start working on Unix was IBM. IBM took the concept of Unix, and then they made it into AIX. So AIX was an operating system. Okay, so you could see that in the early 70s, a lot of jobs were around what do you call mainframes, and you had jobs around IBM COBOL programming. So all of them were kind of on DB2 databases, and then on mainframes, etc. So which means this was the standard of computing, the highest standard of computing at that time. So many people were trying to do things for their own. So if you see, HP took the concept of this, and then I don't remember the timeline, but I'll tell you, it's 70s to 80s to 90s. HP took the concept, Hewlett Packard, and then they made it into HP UX. It's called HP Unix. So then in the late 90s, Sun Microsystems took the concept and then made it as Solaris. So the thing about this is, this was like a general concept. So IBM made proprietary processors. Okay, IBM made proprietary processors. So they call this as X processors. HP Unix, they called it as RISC processors. Okay, and Solaris, they call themselves as Spark processors. So what they were actually doing is, you had different companies trying to create different, take the concept, and they were trying to monetize these kind of environments. Like, and this gave processes to their own softwares. They started making their own softwares. Like, each one of them, each organization started to make their own softwares based on their platform. So if you see, a lot of early American companies started using IBM, and then you see sort of East Asian companies, they started using a lot of HP Unix, and then Solaris also came up in the early 90s, etc. Now, at the same time, what happened was, like, at the same time, we had Oracle was I would say, the only database that started at a very early stage, and you had something called as an Informix, which is a very smaller database, but in probably early 80s, Oracle was the only database that supported all of these. So you can run Oracle database on these processors, etc. So Oracle started developing software stack for each one of them, right? So now you understand that each of the operating system and Oracle stack, you had Oracle databases for each of the operating systems, etc. Now then, over time, what happened is, like, this was a separate market, this was a separate market, this was a separate market. Now Unix by itself branched out into another concept called Linux. Okay, this was somebody called Linus Torvalds. So who is the father of Linux operating system, and he still exists, and he is the guy who actually coined this concept, and the name came after him. So he took this concept of this, and then this was the revolution. Then what happened is that you had what to say, this branched into 246 further distributions. We had only 3 here, but this was actually probably the correct open source version where he accepted multiple people to contribute to this operating system. So what happened is, like, Red Hat took the concept and made it into Red Hat Linux. Okay, then Oracle took the concept and made it into Oracle Enterprise Linux, and then you had SUSE took the concept and you made it into SUSE Linux. And then parallelly, Oracle databases were also supporting these 2 Linux versions. Then what happened is, like, everyone, all of these software stacks started shifting here. So this is how the transition happened. All of these software stacks. The problem with this stack is, like, you have to buy IBM's hardware, you are stuck with IBM hardware, you're stuck with HP, or you're stuck with Spark here. And all of them are independent processors. But here, everything it started with x86. x86 means Intel processor. So you had so many people with one common processor, and you don't have to write multiple versions of software for multiple operating systems, multiple processors. You just have to write for Intel x86, which means if a software stack works here, it will most likely work here. It will work here. So there is an interoperability between operating systems. So which means anything you develop on top of this Linux, any software stack you develop on top of this Linux, okay, will work comfortably across these, but you still have to get the certified. If I am developing an application, I need to develop it for Red Hat or Oracle or SUSE. Most likely it will work with small tweaking here and there. This is all. So most likely it will work with some tweaking here and there. Now this again branched out into another open source called as Ubuntu. Okay, this Ubuntu. So this Ubuntu, this is a completely, I would say, free one. I would say you can develop applications here, and this was kind of the poor man's Windows laptop. So you don't have to buy a Windows system, but you have everything that is possible. You can use internet, you can use documents, you can use OpenOffice, etc. You don't have to have a Windows operating system here. On the parallel side, Windows, okay, they had a monopoly by this time. Okay, they were still only working with Intel x86, and they had, is it my phone? Okay. So and they had only Windows servers, and then a lot of software stack on Windows was still available, and it continues to be the case even today. So even today, Windows starts with one particular process. They live in a separate island. They start in one processor, and they have multiple people who are following their own softwares. So what happens here is, now you might notice that either people are working on this set of softwares, or if you understand the careers, I am a Windows administrator, I am a Linux administrator, I am a so-called Oracle developer, etc. So you're all end consumers to how this world is moving through. So, but nobody really understands the history of what has happened, and why Linux is so important nowadays is, now today what has happened is, after all this now IBM started losing market on all of this. Oracle started this as open source. Red Hat also started this as open source. SUSE also started this as open source. Then what is happening? Then after this is like, say, 1970s. Now today what happens? Red Hat, IBM buys Red Hat, right? IBM buys Red Hat. Oracle starts to give enterprise Oracle Linux. And SUSE gives enterprise Linux. And you see, history is repeating again itself. Now you have the same players, same kind of players doing the same kind of thing again. But the good thing is that you can always branch out your version of Linux and start developing what you want to develop. And you have one, there are multiple, but I'll explain with one. There are one reliable processor provider where you can transport software across each other. Now this is, I would say, until 2010 to 2015. Okay. Now 2010 to 15. So all of these I would say as CPUs. All of these are CPUs. Now parallelly, now just around the time of 2015, everything started getting digitized. Everything starting getting digitized, including our consumer applications to basic communications, etc. Everything started getting digitized. Everyone wanted to, wherever you go to a shop, there is some digital footprint in our daily life. So every application is expected to be online. So where is all this computing power coming from? So it means people like Amazon, they started a concept called cloud. Okay. So all these were open source systems. On-premise systems. All these were on-premise servers where you have to hold a data center like something like this. If I am running an enterprise, everything is in this room and people have to connect from everywhere, and I need 20-30 people to actually manage this data center. In some cases it still exists in regulated environment like banks, etc. It still exists. You still have to have your systems on-prem on the ground, while some footprint is there on the cloud. So which means for people who want to create small applications, like say you take to a shop, they want their billing system. Those people cannot afford to have a data center, and you cannot expect them to have some kind of a data center for them to run their shops. So then what happens? Then people created software stacks on cloud hosted environments, which means everything is virtualized. Now where will you virtualize it? Virtualize it, it means it is still a physical data center somewhere. You are taking some part of it somewhere and you are actually hosting it, and somebody is developing some software on it, and you are actually using a small speck of what is there. Now what infrastructure to use here? The infrastructure to use here, the de facto infrastructure is Linux. So this is why now today you take Azure and you take OCI and you take Google Cloud Platform. Everyone sticks to Linux, because tomorrow if a consumer wants to move from one cloud to another cloud, your platform is stable. Your platform, you have the same platform, which is Linux, and then you have multiple people. You can move applications here, but there will be challenges. But you can actually move your applications from here to here. Today I have a small application. I am running a shop. My billing system is on Amazon Cloud, but I find some challenges with them. I see that some other software provider is giving data in Azure or OCI, but I'd like to move to them. They're giving me good discount. So you can port this application completely here. So there are a lot of porting. Some people move from here to here, some people move from here to here, based on what their own requirements are. So now you see that Linux has become one of the de facto platforms where people need to actually start understanding how Linux, people need to understand how your applications are built over Linux. Then now in today's case, or my core expertise is to handle how this handles in OCI. And in general, I would say, Santosh, marker pen అయిపోయింది తీసుకురా. So in some cases, from my understanding, Linux has got the Now, I'm sorry, the Oracle Linux is the most economical Linux of all the platforms, and I'll explain why this has been the case. Because 2015 Amazon started with Linux, and you see Amazon does not have a, if you see here of the top 5, Amazon does not own a Linux. So they have to buy a subscription from Red Hat, or they had to buy a subscription from SUSE or Oracle to actually host a Linux for them. Azure also does not have a Linux. Azure, Microsoft, they are currently Windows. They are most of their applications are now Windows native, but they also have Linux applications here. So, what AWS and Azure is that they branch out a part of it, which they don't have an enterprise platform, but they will ask Red Hat, they will ask a Red Hat or an Ubuntu here to do that. For that, they will need a pricing for that. But when you look at Oracle Cloud, they have their own Oracle Enterprise Linux platform. So it's much more economical to have a Linux platform at the lowest cost here. So this is the numerics behind why Oracle Cloud Linux is kind of the cheapest Linux available everywhere. You can do your own research to understand how this works, but this is how the entire business of cloud works. Now, whatever we are going to see now is to understand how a small application runs here and how we are going to work on this. So now, given this, before I proceed, is there any clarification that you want to understand? This is more of a history lesson of how Linux works. So tell me, how many of you knew this earlier? How many of you knew this? Yes, good then. How many of you are completely hearing this for the first time? Fine. So which means people so which means we should be technology adapters. We can't be consumers of a technology. Because someone is providing something, I'm using it, but why am I using it? We need to understand this complete background for this. So now what I will do is, I'll explain how this works, and I'll also explain how, I'll give you a background now itself on how a typical Oracle Cloud environment works, and this is the same concept across clouds. So now what happens here is, I have something, let me call it as a canvas. Okay, let me say this is my Oracle Cloud infrastructure canvas. So now Oracle Cloud, in every country, every cloud region would have something called as a region. Okay, we'll have a region. So now in a particular region, so let's say that in Mumbai or a US East, etc. So let's say I'm using a Mumbai region. In this Mumbai region, which means there's a Oracle Cloud data center in Mumbai, which hosts the cloud environment for India. So in that, let me say I am taking a part of it for my application, for my enterprise. So which means I will call this, so I will use in the entire region, in this entire region, I will take a part of it where I will run my application on it. This is my virtual data center, and this is called as a tenancy. I will call it a tenancy. So which means I have taken a part of a data center where I can use all my services there. Now in this tenancy, then I have a lot of logical components called as compartments. Okay, I have something called as compartments. Let me say I will create a dev compartment. I will create a UAT compartment. I'll call it a dev. I'll create a UAT. I'll create a prod compartment. Okay, which means I will have some servers here. I will have some servers here. and I will have some servers here. Okay, and I will create something called as, please come. I will create something called as a subnet. So I'll create something called as a subnet. So what happens is I'll have something called as a private subnet or a public subnet, and I will have something called as a private subnet. So when I say subnet, which means I can connect to external applications. Any application that I have, external applications that I can connect here. And then the moment I connect to external applications, I have a prod database here. And I have a dev UAT. So all these are my Linux servers. So what I'm going to do now is, I'm going to create a small Linux server. I'm going to show you how this exists in the cloud, and I'll run some application here, and I'll create some load, and I'll tell you how do you go about troubleshooting this. So that is what I call it as Linux utilities. One of the regular Linux utilities is what I'm going to show you about. Okay, so this is what I'm going to showcase now, and then once I'm done with this, I'll explain about the different databases that are available, the different class of databases that is available, and then how do you actually have a good production environment in the cloud, how do you handle a disaster recovery, which my friend Suraj has come over from Oracle. So he'll be explaining a session about how a disaster recovery site needs to be carefully configured. Now you'll have a full stack disaster recovery site, but then you need to have a simple application here. So then we'll quickly go ahead with, I'll show you how a application works. I'll show you what utilities are there to monitor, Linux utilities, and from there we'll go to the small lab session. Okay, so you guys can turn around. Okay, so I have logged into my server here. So I have logged into my cloud instance. Let me just show you again. So I have logged in SSH-I, which means I'm using a private key, where I'm using a private key, and I'm using the OPC is the Oracle Public Cloud account, and then the IP. And if you look at the Oracle Cloud, every public IP will also have a private IP. So every public IP will also have by default a private IP. So before I explain about an application, let me just go through and explain you how does a server actually look up in Oracle Cloud. How do you actually visualize a server in Oracle Cloud? Okay, so now, so I have a cloud here. So I have various things. I have something called as availability domain, fault domain, which means there are logical structures inside a data center where in my tenancy, it is like having a server in multiple racks. I have one server in one rack. I'll call it as fault domain, availability domain 1, availability domain 2, etc. Inside a rack, I have another subdivision. I will call it as a fault domain. So it's more of a data center jargon. But for you to understand further, you can see that what kind of a storage that I have, what kind of a networking that I have. Like I said, every application, every server in cloud will mandatorily have a private IP and optionally have a public IP. So in this case, I have both for representation purposes, but mostly in very regulated environments, you will have only private IP there. And then I have storage. So I don't have much of a storage. I just have a 50 GB storage disk where I create my servers. And then I don't have much security rules. I am just allowing anything that comes into it. And then I don't have much management, and then the monitoring will come to it. So now I am going to run a small load on this. So I am actually even before I started this lab, I actually created some load on the system so that I can show you what is happening. So if you see that my system is actually 100% CPU loaded, right? Because there's something very difficult running in my system. So there's something, my system is actually hogging for performance. And if you see this for last, I would say 12 hours. Today morning I started something in this machine, and it's still at 100% now. So let me just say I have connected here, and no, okay, now I am logging into the root system, and then there is something called as so I am actually stopping. I have created a small load script and I am stopping, and you can see here that the system load will come down immediately. So I'll explain you what is happening in the system, what I am trying to do, etc. So now so the load that I am going to generate is like, this is a simple shell script. Those who are new to shell script, now it will be difficult to understand, but what I am trying to do is I am taking a small loop, I am running a load of 2 lakh files, and I am trying to do a file transition into multiple calls. I'll read a file, I'll set up a file, I'll clear a file, I'll copy a file, I'll remove a file. It's basically doing a lot of file activity. This is my application for what I want, for what I want to showcase in the camp, in the boot camp, so that I want to hog a system so high that and how does actually Linux, how do you actually see it as a from the infrastructure standpoint. So when something is hogging so much, you need to understand what is going through there. So I am actually doing a lot of commands, like I am doing an awk is a basic Unix command. So I am taking a lot of files, I am just cutting through text, and I am scanning through a lot of contents in the files, displaying it and removing it, etc. As more what do you call, as the load gets high, we will see that the several parts in the server also gets stretched highly, which is you have a CPU part, and you have a memory part, and you have an OS part. So several parts of the server gets right. So I am generating a CPU load, I am generating a IO load, I am generating a file open load. So it's a single process, it is a single program which will show me a load in all parts of the system. So before I start anything, I'll show you here that yeah, now this has come down. So which means I've stopped everything. So there's nothing here, there's nothing in the system now. There's nothing running in the system. So I would say the first command that I would run is called as the top. So which means that I am not using much of my CPU. There's so many things that are happening here, but you don't have to understand out of it. So all I want to see is one part is what is my CPU operating system doing, and how much operating system I have used in the memory, how much in the swap I have used. So swap, I mean, it's again a memory component. So basically compute server is consisted of 3 parts, which is the memory part, the CPU part, and the hardware part. So this program I am going to load is going to consume all 3 parts of this, and how we will see which part, what is actually happening here, and we will also see a small network part of it. Okay, now let's see here that now let's see here, I am going to run a okay, so my system is running then. So to actually understand what is happening here, I would just copy this here. Okay, so there are a certain operating system utilities. I'll go through my presentation first. I'll show you what are the things that I'll explain of all these things are, and then I'll come back to the lab, so that by the time some load will get generated. So like I said, this is the operating system. So this is how your disk will look like. So once you have a once you have an understanding of how an operating system will look like, you will get to know which part of the system, how do you troubleshoot these different layers of operating system. So even the most complex applications will need to be developed on Linux or will be on an operating system. You need to understand whether the application you are developing is a memory intensive application, it is a CPU intensive application, or it is an IO intensive application. So that is the fundamental thing of any system development that needs to be. So I am developing a new software. What does it really do? Is it IO intensive, CPU intensive, or memory intensive? As I would say, as a person of a data center man, I will say this is the first thing I will understand before sizing a system. Because the moment you start using the wrong architecture for a wrong platform, you are fitting a square in a round hole. It will never fit. So you need to understand how your system is, and then before you start to understand how it actually works. Now these are the 10 commands I will explain. So there is something called as BPF trace. So BPF trace. BPF means Berkeley packet filter. So it will actually explain you. This is a very, I would say, engineers do not use this tool at all. They don't even know it exists. So this is a tool which tells you what is your system call, it will actually go down to the layer of what system Unix call it is happening, and it will tell you, it will actually trace you what is happening in the system. So it will tell you who's doing what. It may not tell you which part of the system it is loaded, etc., but it will give you an idea who's doing what. So if you are running a C program, or most likely even a Java program, you want to know which Java program is actually causing hogging somewhere and what is currently running. So if I have a complex program, so many things are running, but which part of my program is running, I will never know. You need to understand which part of the program. Someone calls and tells you that my application is slow. So you need to go back and tell them that this part of the program is slow, please start looking into it. How will you say that? You cannot use the traditional Windows system that you will restart the server, everything will work. That will never work in real-time system. You need to tell them as an engineer what is running slow. So this will help you identify this. And then IO status will tell you, is basically, as the name says, the input output statistics. How many bytes are you writing to the system, how many bytes are you reading from the system. And there are so many parts of the IO which is more detailed, and that difference will come when you work on multiple storage layers. So if you are having a SAN storage, or if you are having a NFS storage, or if you are having a remote storage, the jargons will vary, but essentially it comes down to IO stats, whether how much are you reading, how much are you writing. And then SS means socket statistics. So socket statistics is basically multiple protocols, like you have multiple socket layers like UDP, TCP, multiple network layers of application there. So your application, which socket it is trying to use, which is actually using more, and for an engineer to understand more about an application. If your application is socket intensive, you need to have you need to size your system in such a way that you have comfortable UDP or a TCP layer for your application. So it's basically you calling multiple APIs. So it's most likely 90% of the applications are in TCP layer. So a lot of other sockets are more of an internal in the system. We'll come to that. S-trace is like syscall tracing. This is a very complex tracing tool, but this will actually give you a complete core dump of what is happening. So this you should not be using in regular environment, because this will trace everything that is happening. It will take a lot of this itself will run as a complex application. You should use this only when when your system, you need to know everything that is happening in your system. This is like your master health checkup. It will tell you everything, but it will take a lot of time to work. And then Nabhaas, it's like the memory part of it. So basically people use a lot of utilities like free or SAR utilities also tells you in memory, but Nabhaas will tell you how your memory is differing, how your memory is changing over time. A lot of components in the memory will be there, but This will tell you whether your application, it will give you a continuous information of whether your application is, how your memories are progressing. I'll showcase this in our lab. And SAR is like, the de facto tool in all operating systems. SAR is System Activity Report. It will give you basic information about usage, about your CPU. It will give you usage about your memory. It will give you usage about your kernel, etc. So this is a SAR is a utility by default in Linux. It will be logging all the time. So you can actually query the SAR report from a Unix command and query how your system is actually behaving. So you need to know yesterday 4 p.m. 4 a.m. what was my CPU load. You can just query it from your command. You don't have to go to your web console, etc. Perf is again it's kind of more of a dashboard kind of a thing where you will get it will tell you that which application is the most consuming. So this is the one which will tell you, which will point you to the direction where which consumer is causing a lot of load on the systems. LSOF is files and sockets. So which is LSOF in other terms, which list open files. Let's say that you are working with a billing system, and today you have about 20,000 bills generated, and at any point of time you are always using 5,000 bills at a time. So your system needs to handle multiple open files. So if your system is IO intensive, and in Linux everything is a file, so and you need to have high amount of files to be opened, and you need to know how many files are being opened. So ls is list command, OF is open files. So list open files will tell you how many files am I actually working with. And IPCS is inter-process communication status. This is something again I'll explain you in the lab. And watch is my favorite command. Watch, you can run any command and watch. I want to watch a command for 1 second, 2 seconds, 3 seconds, etc. So I want to run a pneumostat command for every 5 seconds, 1 minute. I can keep running the whole thing again. So these are 10 different utilities in one small lab, which will tell you how your application is working. So it means anyone who is running an application, you need to understand how the operating system reacts to the application. Operating system will always react to whatever the application is running. A good application is when everything application will work as good as your hardware is available. So if your application is hardware intensive or IO intensive or CPU intensive, using these tools you can design your application first. So in cloud everything has become easier now, saying that you have customized shapes. You can use that shape, you can use this shape, but you need to know which shape is IO intensive, which shape is CPU intensive, which shape is memory intensive. So that knowledge everyone should have, whether it is an on-prem or a cloud or or your own small lab. You need to understand which shape you need to use, because it invariably comes down to the cloud cost. If you're using the wrong shape, you will have two problems. One is you will not get the performance you want, and you will be paying more money for things that you will never use. So let's come to the the lab. So this BPF trace, basically I want to understand what kind of so if you see that my program, it does a curl, it does a RM, it does a sleep, it does so many Unix commands at once. And I am doing so many files, I am reading 5,000 files, I am clearing files, I am reading, I am doing so many operations at once. So this is the exact trace that for people to understand that how is my program working? What is my program doing? This is like your CCTV camera, everything is working. This is what is causing my system load. I have one script, but that one script is doing so much activity. So this is the packet filter where I understand the system call here. So what is the system call here? So I am just, the most important command here is to understand syscall. So forget about all the syntax, which we will come to it later. I want to understand what is my syscall, and this everything is my syscall. I have made it easier for you to read here, but the end point is to understand what it is doing. And then the next part is so SAR is system activity report. Okay, so you can say that, you know, I can say one this. So every second I want to know what is my CPU user percentage. When I say user, it means I am as a user, I am running something, I am running an activity, and I have like say what is my CPU percentage of all this. So what is my system percentage of all this? Tell me how many reads and writes are happening. So this is a more detailed output. I could say sorry. So how many KB is written, how many KB is read, etc. Read per second, writes per second. So these are basically the files that I am writing right now. And then I have so I am just doing a perf. So this will tell me what part of my program is taking the maximum, which is contributing to maximum percentage of system activity. So I am doing an awk programming in my script. So that is taking the most percentage of my program. So this will tell you which programs in terms of percentage. This is somewhere similar to your Windows Task Manager. In Windows Task Manager, you will see which program is taking which percentage, etc. So this will help you understand that which program is highly used in the application. So if you see, all these are default system utilities, but those are the ones that are taking most time. So all these will help you understand how your application is working. So you have a Java program file or you have a Python program file, but you as data center people, we will never understand how a program is written, but we can understand how a program affects the infrastructure. So now let me say list open files. Now I am running this in the report. Now so you see, so many open files are there. So why am I having so many open files? So which means my program is opening so many files. 7,000 files I am opening it. Every second I am opening 7,000 files. It is opening and it is closing, etc. And then strace. Now like I said, this will tell you what is actually happening in the system. Yeah. So you can see here that this is a small trace that I took for 10 seconds, and about 90% of the time my system is waiting for something. My program is actually waiting to read a file or waiting to write a file or waiting for a file open to complete or a file close to complete. So this will tell you that this clone means here, it means that it is trying to copy a file, etc. So this will tell you how much percentage of time what is actually happening. So it means my program is waiting on something to happen. So that waiting on something, what only my application will know. So the bulk of the time is actually used by a wait program, which is internally the awk program that is actually making the system wait. Now let me show SS-S. Now this is an interesting program. Okay. Now you have sockets, like I said, every application has multiple sockets. How do I how do I interpret this? So most of the application program are with the TCP protocol. It will run here. UDP is something internal, raw is something internal to the OS. What is INET? INET is the sum of all these. So at all point of time, you can see here that at all points of time, so many protocols are running here. So this is a cumulative count. This will always keep increasing, but you will see out of 1238, 1219 got already closed. So my network protocol is trying to use a TCP protocol 28 times. Now I will use something called as a watch. This will be very useful for you. So So this is probably my favorite command. So you can see here, as my program is running, my TCP counter keeps increasing. So it is always an increasing count, but that doesn't mean system is loading. That means that out of 1281, 125, this part gets closed, and you are having a timeout await events, and then you are seeing that 31 is this INET is the sum of all these. So it is a dynamic statistic of how my ports are actually working. So this is actually an example to show you how my sockets in the server are working. My sockets are primarily using TCP ports and some amount of default raw and UDP ports, and my INET is a sum of all the ports that are running in my system. So if your application is TCP intensive, then you need to size your system accordingly. But how to do that comes with system administration, but everyone needs to understand, is my application like CPU intensive, memory intensive, IO intensive, or which means or even network intensive. So let me come to my next part. So this is a very complicated part, but let me simplify this for you. Now, memory, Linux memory by itself, when you have, let's say, 2 GB of memory, Linux will always say something called as, so Linux, when you say everything that is available in memory is called 9 GB is my memory, and I have a swap of 3 GB. Swap is like a temporary space where some swapping of the application happens, and most often a performance issue of an application will be from swap, most often, and ideally your application should not swap at all. So this part should actually be used should be literally 0. In this case it is 0, but in some applications you see that you see as 1 or 2 or 2 GB, or which is 5 to 10% of your application. So here you have so many bytes that are allocated to the system. So all these bytes that are allocated to the system are changing all the time. In this case it is fixed, but IPCS will tell us how to understand memory architecture. So this is like a bit complicated, but I'll explain this at the later part when I show the NUMA stack. So this will give a more logical understanding of how your memory is allocated. So the other ones will tell you components of something called as shared memory block. So the IPCS will give you more details of this one, but this will kind of give you an overall picture of how your memory is allocated to your system. So if you want to understand the dynamic part of this, then let me show you. So the highlighted part here will actually tell you what is actually changing. So when you run this, you consistently see that some part of memory is used, some part of memory is released, etc. So this will help you understand how your system memory is actually behaving. In some cases, you have to allocate more memory to your programs, etc. But for you to really understand how much it is currently using, this will give you a clear stat. So these are the kind of 10 regular utilities, and believe me, each one of them can go deep, very deep easily. But these are kind of 10 things that will tell you to understand utilities of how a system is working. So now this is about the Linux part. Now when you say over on top of Linux, you have databases. Now there are different classes of databases. So in Oracle you have database base service and you have a XRCS database service. Now you need to understand which service to use when. So it depends on for you to understand. I think most DBS here, you know that there is something called as a base database service. You know something called as an XRCS, but the differences between them needs to be understood clearly. So these are the, I say, 10 different utilities. So I'll just go through all these in summary. So like I said, Berkeley packet filter, it will tell you this is call that I want to use here, and then SAR is system activity report. I want to see the percentage user, percentage nice of a system, percentage of how much percentage of my program is being used by the CPU, and then IO stat, again reads and writes per second, and then perf is a tell you which program constitutes most amount of the server time, and then socket statistics, different kinds of sockets, how they behave over real time, and then strace will trace the complete system activity, list open files, number of files that are open, which files are open, at what port they are open, and then IPCS, these are shared memory statistics. So if you have a memory, and you can actually have different kinds of memory configurations, which is DBS would understand further. When you have a shared memory segment, your memory should not be swapped. So there are configurations of how your memory is used. So this will tell you how your memory is actually used. Let's not get into details of it, but NumaStat will tell you how much memory is available, how much is used, and how much is allocated to the overall server. And then watch is a program. This is my favorite program. I can use any program, whether it is df-h, watch-n, number of seconds, -d, difference between the previous output and this output, and the Linux command. So this will actually tell you an overall understanding of what is happening in the server, and will give you an understanding of how your application needs to be designed. So any administrator who is working on Linux, these commands will help you identify what will it will help you, I would say, equip you with more details to talk to developers. See, your application is memory intensive, provide more memory, or your application is growing continuously, you need to provide more hardware, you need to provide more IO intensive hardware. So these kind of things is what typical cloud engineer needs to understand. You have a ready-made system, you provision it, but there are issues like what I am showing here. You have a system, like you set up a cloud system, but load is always 100%. You don't know how to use it. So the next session is on OCI class of databases. Before that, I just want to understand on Linux part, you have any questions to ask, or if you have any clarifications. You might be perceiving that Linux might be working a bit differently. I'd like to have some questions. Yes, sir.
You started your job with a nice command numbers.
Come again?
You started your job with a nice command.
Yeah.
I would like to see your CPU usage architecture.
It will still be 100%. The only difference is the 100% is which is taking 100%. My application is taking the bulk of it by slowing down my system, or my CPU is taking 100% by ensuring my application is faster. It is the same 100%. I have 100%, 60% of it is by default, 60% of it is used by the application, 40% only is given to the servers. So then what happens? My server starts slowing down. But by reversing it, I will say 60% I give it to the server and 40% I will give it to the application. So which means that my server is always safe, but my application will continue to be slow. It is still 100%, but your program will run a bit slower. It will still, you see that? My program is still running on nice here. If you see here. My program is still running on nice here, and my load is still 100%. But the breakup of 100% is what is important. Am I giving more to my system or more to my application? But this can't be a ready-made solution for every poor program. You still have to push the application teams to ensure that the program are not resource intensive. But this is more to showcase the options that are available at the server side. So now, before I begin this, what we will do is I'll give the session to Suraj. So he'd like to showcase a few things because he's on time-sensitive activity. So we will till 4:45 to probably 5:20, he will take a session, and post that we'll take a small session on the databases, and then we can take for a break. So that's okay? Yeah, fine.
So I'm Suraj. I'm one of the product manager in Oracle database product development team. I just want to understand the people. So here primarily are DBAs here. Who are all DBAs? Cloud admins. Okay. So who are the rest of the people are what background you are from? I'm asking you guys only. Sorry? Marketing, okay. So mix of technical and non-technical, right? Okay. Okay, cool. So I mean, our team's responsibility is all the HA and DR products in database, right? Like things like DataGuard, RAC, which DBAs are familiar with. So we are the product managers who work with the development behind the scenes with customers and make sure the product things gets enhanced, right? So I am one of the product manager in the high availability and disaster recovery product team. So I'm going to talk about a native DR service in OCI, which is called full stack DR. So before that, I will give some background about Oracle MA and what the products which comes under that umbrella, and then we'll talk about the service itself, right? So that's the plan. So these are my social handles. If you want to connect, please. So I post primarily only technical stuff, no social media stuff like that. Okay. So do connect with me in LinkedIn, and also I blog about any technical stuffs and things like that in my blog. Okay. Kekla. Do you want me to use that? Okay. Satha pesa. Okay. Pinnadi kekkuda? Okay. Okay. Sure. Anyone knows what is maximum availability architecture? Okay. One thing. Good. So basically, it's a framework we have in Oracle database products. Right. So what exactly this is? We have various tiers called bronze, silver, gold, and platinum. So what this does is like if you are using database products like DataGuard, RAC, Exadata, and things like that, right? We have a group of team within Oracle who create these reference architectures, and we provide this as a reference to our customers. And then depending on the RT1, RPO, you can follow those best practices and then use that accordingly. Right? Let's say you are a bank, you want to have a zero RPO and then minimal RTO, then probably you will follow the highest tier of things like that, right? So this is a framework we create and provide it to a customer. There is a big team in Oracle who works day in, day out of this kind of reference architecture. We do chaos testing. I'm sure people know what is chaos testing is. We break the thing stuff, right? So we'll pull the cable and see how it behaves, right? So that we document all those things, so that whenever a customer comes up with these issues, right, they will know what things they need to do, right? And again, as I mentioned, it's integrated with various technologies, right? It's not just one technology like that, right? Okay, so this is the overall tier, right? For the folks, it's good. It's only one person know about what is MAA, but if you look at, right, what are the tiers I talked about: bronze, silver, gold, platinum. We recently came up with something called diamond. I'll talk about that. But again, as I mentioned, all these technologies, right, which you're quite familiar with, the DBAs especially, data guard, rack, RMAN, flashback, online redefinition, golden gate, globally distributed database, everything comes under this umbrella family. And then, as I said, we provide the reference architecture, and then you deploy it depending on wherever you want. A lot of customers will be in on-prem, a lot of customers in OCI, a lot of customers in multi-cloud. Everywhere we have the reference architecture available, right? Again, as I said, it's available across the board. So if you just want to take one, thing out of this, right? This is basically a reference architecture we provide to customers, and then depending on their RTO and RPO, right? They choose it and then they deploy it according to their requirements. Again, I'm not going to delve deep about what exactly it is, but just to summarize, these are the recommended or the documented RTO and RPO which you get, right? So generally people start with bronze, right, which is applicable for the lower kind of system, right, where you don't have a lot of mission critical production system. That's why it's applicable for dev system, things like that, where the RTO is relatively higher, and then also the RPO is relatively higher, right, because we just use single instance backup and restore, right, and then things gradually will increase, right. If you look at bronze, we basically use feature like rack or data guard, right, but that's only applicable only in one data center, not multiple data center. And then gold is the one, it's a kind of a standard every customer use, right, where you have one production data center, one DR data center, you have data guard between, and then you have rack, things like that. And then up the layer, it's basically mission critical and extreme mission critical, right, where things like banks where it cannot go down for a minute, or things like airplanes, systems, those are all, and all the healthcare system where they cannot have a downtime. They follow things like platinum and diamond, right. So again, just to summarize, these are reference architecture, not any product per se, but if you want to follow the best practices from Oracle database, right, especially with your recovery, things like that, then you should look at the Oracle MAA products, right. Okay, so coming back to the main topic which I want to talk about is the disaster recovery service in OCI, right. Before that, I just want to know, though Abhilash mentioned about, OCI console and everything, who are all OCI users here? Okay, for the folks, maybe I'm assuming you know about other clouds a bit, not OCI, right, at least, okay. Good. So what exactly this service helps you to do, right? In simple terms, let's say you are using your production system and a DR system in two OCI regions. For instance, in India, we considered Mumbai and Hyderabad, right? These are the two data centers available in India. So customers deploy the production and a DR in two data centers, right? Application, database, infrastructure, whatever, depending on their requirements. One of the main thing will happen once they deploy the DR is how they can do a switchover or how they can do a failover, right? That's where the tricky part comes, right? Because those are all time sensitive or time bound activities, right? Because let's say you have a outage in your primary data center, you need to quickly fail over to other region, right? Every minute, every second counts, right? Because if there is an outage to your production system, you're losing business, you're losing money, you're losing customers, right? So you need to have a built-in automation which helps you to do all this recovery process, right? So that's what exactly this service does, right? From how you manually move from typing a command, going to a console and doing a switchover of a database, right? Like let's, if you're a database, you go to a broker and type a command switchover, or else click the base DB service, click switchover, right? And whatever preferred way you do it. But by using this service, you can completely eliminate the operations one by one, and then you can just push a button to do the recovery of the full stack, right? Not only the database, app, infra, database, and whatever it is part of your business system, right? So yeah, I'm sure everyone will be able to relate this, right? If you have been any database, drill activity or switchover activity, generally you get called in to perform, okay, hey, can you do a database switchover? Can you stop this application? Can you do this applications testing, right? So it basically goes through a kind of a run book kind of way. You do a switchover or failover, and then eventually once it is done, right, they run out, they complete the process and you hand it out to your business system, right? This is a typical way of doing it, right? What if we transform the same thing into a fully managed service in OCI? You create a similar built-in, plan through a managed service in OCI, and then you push a button to completely automate the recovery process, right? So that's the business value you get by using this service, right? I hope you understood. Any quick questions on whatever I've talked about, especially the full stack DR service? Cool, right? So you just, in nutshell, if you want to summarize again in 10 seconds, it's how you automate your DR recovery process from one region to another region through a fully managed service in OCI, right? That's what we'd exactly do. Okay, so this is what technically what the service is, right? So again, we have two regions, primary and DR region, right? And then we have the database infrastructure, all the things I've deployed. The key thing is the replication, right? That's the important thing. So for database, everyone use Oracle Data Guard for doing the replication from one region to another region. Similarly, for other things, you use native block storage or file storage, depending on whatever services you write. You have the underlying core native replication APIs. We use that behind the scenes to do the replication, right? And once that is done, then you can use our service to orchestrate the switchover or failover from one region to another region, right? And again, so we have built-in integration with all these services. For the folks who already work in OCI, it's quite relatable, right? You have things like virtual machine, which Abhilash talked about. We have integration with all the core database service, BaseDB, ExaDBD, Autonomous, and also we have integration with Kubernetes engine, which is the managed Kubernetes service in OCI, and MySQL DB and bunch of other things, right? So what is the significance of this is once you put this into your recovery group, right, then automatically this service will figure it out, okay, what I need to do in order to recover your application or infrastructure or your database, right? So that's where you get the benefit of automation. You don't need to figure it out what exactly I need to do a switchover. Rather than that, you just pull in the details and the service will automatically help you to automate the recovery operations for you, right? And again, I'll show in the demo wherever possible. It's very easy to use and implement. Once you have all the prereqs taken care, right, it's just matter of clicking a button to invoke the PAN operation, right? So you don't need to navigate through various screens to do all those stuff, right? And maybe this will be useful for the non-technical folks, right? Maybe if you want to convince your customer, right, why they want to do this, right? Because obviously customer will think we already invested in DR, we are doing it, but why automation, right? The number one thing is you can recover it in matter of minutes, right? Because as I said, every downtime or every outage to your application costs money, which eventually means business loss, right? But if you have an automation built in like this, you can do recovery of your applications in matter of minutes, right, rather than doing it matter of hours, right? You can do your recovery at scale, and it's pretty easy to use. As I said, it's a native service, so you are not doing something out of the box or out of the standards. It's a managed service in OCI. So Oracle itself take care of all the heavy lifting, and you just use the service whenever you want to use, right? And then eventually it optimizes the recovery process, which means you get best of your DR investment, whatever you have in OCI, right? Okay, so
Is it available only on OCI or even on customer premises?
yeah, that's a good question, sir. It's available primarily on OCI, which means your production and DR must be in OCI. We do support the multi-cloud offering, which is Oracle Database at Azure, which is a new offering which came recently, Azure, AWS and GCP, but again that's only for the DB stack. But for the full stack, it's only to OCI. We are planning to expand it to hybrid or other kind of setup in future. But as of today, if you want to use this, you have to have your production and DR in OCI regions. Yeah. It can be public cloud or anything like sovereign cloud or DRCC, whatever it is, but it should be the OCI managed regions. Yeah, that's important.
Thanks.
Yeah. Okay, maybe since I have 15-20 minutes, right, I don't want to go through a lot of technical details. I'll just show you some demos so that you get a grasp of it. And of course, all these materials are publicly available. You can look at it. So one of the important thing we get a lot of questions is customers or implementers misunderstand what exactly it does, right? Because they think by using full stack DR, I can just push a button to set up DR, right? So how I can say, like, let's say I have 2 VMs in Mumbai, okay, on database running in Mumbai. They are thinking, okay, after I use this service, I can automatically set up data guard in the region 2, and then I automatically do all the replication. So that is something we don't do. So foundation prerequisites are important, right? Which means you have to configure all your native replication across the layers, set up VCNs, all the stuff, and then prepare your replication, all the things, right? So that you have all those fundamentals created and then start using the service, right? Which is quite important, right? So before using the service, you must have the replication and all the networking pieces plugged in and configured accordingly. Then you can use the service to automate your recovery workflow. Okay, so maybe I'll spend couple of 2-3 minutes to explain core construct so that when I show the demo, right, you can visualize what exactly it is. So we have a construct called protection group. You consider this as a logical container, right? So now let's take a simple example. You have a, let's say, HR application running in OCI, right, in Mumbai and Hyderabad with production and DR. What you create is you create a protection group for HR in one region and then other one in another region, and then you associate the roles saying Mumbai is my primary and then Hyderabad is DR, right? So this is a foundational thing, you do it, and then you can start adding all the members which I showed you, right? Compute, database, storage, all the things depending on your application requirement. So let's say if your HR application is using ExaDBD, right, or XSES or BaseDB, you configure the database running from that infrastructure into this protection group. Or else, let's say if it is using autonomous, you use that, right? So it all depends on what kind of topology you use, what kind of services you use, and then you configure it on top of it. And then once, that's what I mentioned, all the members we support, depending on the topology, you add it to both protection groups, one in primary and one in standby, right? And once you do that, you can create the plans, right? So this is the next level of implementation you do, right? The plan is where you actually go ahead and run a plan, right? So it can be a switchover plan, a failover plan. We support 4 types of plan: switchover, failover, and drill. So the difference is switchover, as the name suggests, right? If there is a requirement to shut down the things from primary and then start up the things, you use the switchover plan, okay? Failover is where you have an outage, right? Let's say there is a big hurricane in Mumbai, your Mumbai data center, it's gone. Then if you think, okay, I need to quickly failover to Hyderabad, then the failover plan will basically just do a failover of your database applications and then bring your things in the DR region, right? And then if you want to do any kind of mock testing, so this is very popular with especially customers in compliance regulatory thing, where they do a testing every 3 months or 6 months without impacting the production. So you can use features like refreshable clone, snapshot standby in database, right? So that without disturbing your application, you can open an environment in an isolated state in the DR region and then convert back to the original state, right? So this is something we also support, right? Okay, so with this fundamental, probably I will show a quick demo so that you can understand what exactly the service does, right? When I am just logging to OCI console. So I have sit here. Yeah, so I am using 2 regions. Mumbai, sorry, not Mumbai, Ashburn is my primary region, and then I will use Phoenix as my DR region. Again, guys, stop me in case if I just want to have a conversation. It's very casual discussion, nothing official. Even if you have any simple questions, silly, don't think about any silly questions or anything, stop me in between if you don't understand what I speak, right? So I was referring, right, we have a construct called a protection group. So this is a navigation menu where you can say, if you want to go to the full stack DR service, right, you just click migration and recovery, and then you have a section called recovery. So which you click, if you get that, then you will see a landing page of our service, right? So it basically tells, okay, this is my primary and this is my standby, right? Things like that. So I have a primary and standby. It's broken, that's why you don't see it, but yeah, it just shows you the relationship between various protection group. So what I want to show you is just a quick set up what I have. So this is my, so if you notice here, this has a role called primary, right? This is important, right? Every protection group will have a role. So Ashburn has a role called primary. So in the other page, I will open the Phoenix one, which you will see basically as a standby. So it works as a pair. So every protection group will have a pair. One is primary and another is standby. So this one you see, it's standby, which is my Phoenix, right? So this is the first thing you will do. And after that, you can go ahead and basically add the members which I was referring, right? So for this demo, what I was trying to do, I have a OKE cluster and an autonomous database and then an associated disk, which is part of my OKE cluster, the persistent volume. And then in my standby database, protection group, I have the respective OKE cluster and the autonomous database. Again, you can manage any members you want and add, right? Like we have whole slew of members which we support, like things like compute. These are the base database, Exa database, ExaCC, ExaScale, autonomous, MySQL, all the storage, right? So in my demo, I just kept it pretty simple, where I just want to show, okay, this is my manage member section. Then once that is ready, right, you can create a plan, right? So I already created all the plan types which we support. So you can just create a plan, like click here, select the plan type and give a name, and then matter of minutes you will have a plan creator, right? So let me just quickly show you a switchover plan, how it will look like, right? So yeah, so you can see it's a very simple application. I just have an OKE cluster, a database and an associated storage, but all these recovery steps, right, the full stack service have created for you. So you are not doing anything manual. Like, so when you associate any plan, right, switchover plan, you do a switchover in the production region, stop in the production region and then start in the DR region, right? So that's why you see things like, again, if you don't understand the nitty-gritty of all the details, don't worry about that. But what I want to show you is all this built-in automation, right? Wherever it says, it's all created by the service, right? So you as a user or as a customer, you are not doing anything. You just configure what you are using in your application. And then once you create it, the service will automatically create it for you, right? So example, here I have an autonomous database which uses for switchover. I have an OKE cluster which basically, being it's a just switchover plan, it removes the things and then it restores in the DR region, right? So once I am done that, if I want to run a plan, right, very easy, just come here and execute a plan. This is the experience I was referring, right? Think about, I just have a very small plan which has maybe 7-8 steps. In a complex customer environment, they have a DR plan with 500-600 steps. We have customers who use that kind of a complex plan. So if you have a plan like this which is automated, created in such a way, the experience as a customer they get is just pushing a button, right? And then all these recovery steps happen through an automated fashion. Of course, there are chances it will may error, or it may fail, or it may not run properly. You have all the observability mechanism, you can do it. But the one thing which I showed you is how quickly you can do a switchover or fail operation, right? So example, this is the plan I was running it on the other day. So if you look at here, we have all these steps, right? So you can click here, you can click view log, you can see what's exactly it done, right? So everything you can do from a single pane of glass experience, right? Rather than going through an Excel runbook, navigating to various consoles, you can just use the managed service to do the DR operation, right? So this is what exactly it does. Again, I can talk about for entire day, but since we have short time, I just want to show a quick glimpse of what exactly this does, so that if in case you are working with your customers, or if you have a requirement to automate your DR orchestration, this is a go-to service in OCI, which makes a lot of sense, right? Because you have already invested in DR, where you want to have a DR system. If something goes wrong, you want to use it. But on top of it, even if you automate it, it's kind of icing on the cake, right? It basically helps you to recover fast, and it provides a lot of experience for you, right? And maybe a couple of things I just want to show before we wrap up is we done some couple of AI enhancements, so that maybe I thought it might be interesting to you. So one of the things which we did is, so as I was showing, right, any step can fail, right? So here all this is succeeded, all good, but there are chances the steps can fail, right? So what we have done is we have integrated with our, we have in OCI some generative AI service, like any other cloud. So what we did with full stack DR is we integrated with our generative AI service. It provides a quick kind of an introspection with the generative AI service. Just let me just show you so that you can understand what I was referring. So here if you look at this is one of the pre-check I ran. So what it does, sorry, I think I was going to a different one. Yeah, so we have a plan which got cancelled. What I want to show you is like one of the step got failed, right? So if you look at my database switchover got failed. So generally what you do, you will go to view log, okay, you try to read it, okay, to understand what it went wrong, or else let's say if it is a very complex step, right, you download the log and then you open it in a text file, right, text editor, right, and then you go ahead and read it, okay, what went wrong, so that like eventually you will figure it out what it went wrong, right. But the AI integration which I was talking about is, so any failed step, right, you can just click this view summary. So what it does, it directly talks with our generative service within OCI, and it provides a nice output for you to understand why it failed, right, and what kind of solution you can take it, right. So this will be very useful, especially if you are running a big plan which has lot of steps, which can, if it is failing, right, this feature will help you to quickly navigate to the problem and also help you to take the necessary action for you, right. And then one final.
So we have something called the pre-checks before we run the
Correct.
like the readiness of both, right?
Correct.
The chances of getting failure. So do we have something called pre-checks before we execute?
Yeah, sorry, probably I missed it. Yeah, every plan has pre-checks. So as I was showing, right, let me go to a plan which is in my DR region. Right, so I just showed you, I think, only the execute plan. But if you want to run a pre-check, let's say I want to run a pre-check for switchover, you can just say run pre-checks, right, which it will just only validate the readiness of your plan, which will not actually execute. So you can schedule it every, let's say, whatever, depending on your customer requirements, so that they are confident of their plans are ready to go, right. So this is always recommended to try it before you go, right. And one thing maybe interested for you is, I hope everyone is aware about what is MCP server, right? Do you know what is MCP? Yeah, Model Context Protocol, right? So what we have done in Oracle is, maybe I'll explain that to you in a bit. Yeah, so we have a GitHub repository available, publicly available for all customers, okay? So what it does, right? MCP is basically, for the folks who are not aware, right? You can think like a USB connector for your AI application, right? So let's say you are a ChatGPT user, right? Let's say you are a ChatGPT user, you can ask any questions, right? It provides based on whatever the model knows, right? But let's say if you want to use the same ChatGPT model to interact with your databases, right, in your customer environment, or to interact with, let's say, a custom data available in your place, right, or any publicly available service which can be configured, or in layman's language, right, maybe you would have seen in demos, there are things like that. Let's say if you want to book a flight, let's say from Chennai to Delhi tomorrow, so ChatGPT cannot directly do it, right. So there are connectors which connects to, let's say, ibo.com or whichever travel website, which provides the data from that website, and then it provides the details, okay, how you can book the tickets, right. So that's what exactly the MCP server does. Okay, 5 minutes, right. MCP server does, it basically provides a kind of a connector which can talk to the full stack DR service, right. So by this you can basically ask questions in a natural language to converse with any of your OCI service, right. So for the folks who are using let's say XRDBD or BaseDB servers, if you have access to any of the models which I was talking about, you can configure the MCP servers and then do it, right. So let me just show a quick demo. So I have access to codecs in our Oracle enterprise behind the scenes. So I have configured the MCP servers for this. So I can simply ask, so we have something called tools which we have created for this service. So let's say I want to ask a quick question, right. I don't want to spend time reading about Okay, probably I will just show what I ran before. So I think maybe I was doing a demo on the other day to one of the other customer. So maybe I'll show this to you. So I was just asking a question, okay, what are the tools available? And then I'm asking, okay, these are my, can you list down the protection group in these regions? This is my compartment ID. Then since I have my MCP connector configured, it was able to understand, okay, this is my tenancy which is configured and it has access to all the full stack DR APIs. It was able to fetch me and provide all these details, right? So again, the idea is to just show you, you can naturally converse in English to do all the activities, right? So even you can do entire configuration, like I think I was doing the other day, showing, okay, the protection group and everything which I was configuring, right? Everything you can do through MCP servers. Like you can say, can you create a protection group? It can do. Can you run a plan? It can do, right? So the idea is to show you the flexibility we have in terms of working with AI tools. And again, if you are interested to understand more about this MCP, I would recommend to go to this GitHub repo. So there is an Oracle MCP repository. So we have MCP servers for various services. So if you see, we have MCP server for compute database. So this is the one for full stack DR, right? So if you just go here, it will have the source code. You can just clone it, and there are a bunch of prerequisites. Most are very straightforward. And once you have that, then you can up and running in few minutes, right? So I'm already warned by Abhilash, I'm running out of time. So I just want to finish this quickly, this QR code. So I run an office hours every monthly once. So similarly, what I presented, right? I present all the latest topics, all the enhancements which we do, and also we bring customers to share the success stories, right? So if you are interested, subscribe to this office hours. It's free office hours. It's primarily casual technical discussion, like how we are doing. So if you want to understand more about what we are doing in full stack DR, the first one is full stack DR, the second one is for the mission critical database. So the DBAs who are interested in HADR, all the products you can subscribe, and the first one is for the full stack DR, right? So with that, I'm done. I know I rushed a bit because I have to go for a personal work, but if you are interested more, happy to do it again in future sessions. Thank you so much.
What you're seeing here is actually, once you are into Oracle Cloud, then you always have to plan your disaster recovery at some point. So regulated environment, you will have a lot of disaster recovery planning. Once a year you have to do a DR. But for that you need to have your PCI cloud framework ready so that you can do a DR. Most typical enterprises you have to do a DR to one shot, DR 15 years or 10 years or 1 week or 3 4 years. So once you have this kind of automation ready, so you can focus on building your application. So that's what we are taking this time to come over. Easy product manager for Oracle, full stack development. So he takes care of, he goes to customer side, he searches for this kind of application.
Yeah.
Before we do it, first we have to enable a cross-build application for all storage.
Yeah, that's a prerequisite. Like if you are using Oracle database, Exadata, you have to configure data. Let's say if you are using compute storage, like you have to configure this.
Once we done all setup, first we should be running all the time or?
No, it's up to your requirement, right? So if you want to have a switchover, if your customer asks, okay, I want to do every 3 months, you can use the plan. And the eventuality thing I mentioned, right? Failure can happen.
Rest of the time we can stop it.
Yeah. See, maybe again I forget to tell. You think like insurance. Use it when you want to use it, but pay it as long as you use it. So that's the analogy I tell to customers. So again, it's pretty cheap one to use, right? Because again, it has a lot of business benefits, things like that. Customers think about, I'm already invested in DR, why I have to pay extra for that? But if you think about consequences of not having an automation, it's huge. Right? We have seen customers struggle for days to recover because they might have not properly configured it properly, or they may miss something. Rather than stopping A system, they will stop a B system, which can create more even outage.
What about cost?
for using this, there is an associated SKU of CPU cost. So if you go to our product website, Fullstack, just search Google Fullstack here. There's a product page available. You have a pricing calculator. In roughly, if you say for one more CPU, it will cost $30 per month. It's very cheap.
So if resources are running in a DR region, so the cost is very high.
Yeah, that is DR investment, right? You cannot avoid that. See, if someone using a DR, they know the importance of DR. Right? Okay. So, see, any cloud
Usually, we do once in a year. So, was it a
okay. So, you were doing for a planned one.
Yes.
But unplanned one anytime can happen. That's what I'm saying. So, see, I work for Oracle, but I am not saying Oracle Cloud can run 100%. Right?
Yeah.
Any cloud can do it. Right? We cannot predict tomorrow a tsunami can hit Mumbai. Right? Who knows? Which means it can bring down the data center. Right? Okay. Anyway, thank you so much.
No problem. So we'll take another. The second session is what I'll take a few minutes before we go to our break. So the difference is like what we've seen earlier was like we see a application, we see how it behaves. Yeah. We're not able to audit.
Your voice is not audible. Your voice is not audible.
Okay, I'll be a bit louder. Mic is not working. I'll try. So what's the difference between earlier what we saw was an application server, how the Linux operating system behaves. Now the same Linux is configured to handle a database server, and there are different classes of database servers. Like in on-prem you have a standard sizes where you have to add more memory, you have to add more storage, you have to add more network cards for clustering, etc. But in cloud environments, you have basically three different sizes. One is OCI based database service, and second one is Exadata cloud service, and third one is Exadata cloud at customer, which is not in the scope now because you can have your private data center calling as a private cloud. So right now I'm just focusing on these two. So what are the difference between these two? These two basically essentially are still Linux servers, but they're configured differently for each databases. Now here if you see, base database server, you have the different size of shapes. You can scale up, scale down the environment, but you cannot scale up all kinds of servers all the time. So which one you should consider how? So basically, if you see this base database service here, the left one is the base database service. It's a fixed shape. It's a single node database with available database ASM storage, and it is available memory, and you have a single setup. So if you want to scale up from one shape to another shape, you have to there will be a downtime where you will move from 2 nodes to 4 nodes or 4 nodes to 8 nodes. But it is not the case here. You have horizontal scaling and you have vertical scaling. You can scale up more CPUs, you can scale up more nodes also, which means here it is only a single node, here you have multi nodes. So the difference is that you can have multiple clusters here, each cluster having multiple databases here, but that is a standalone system. So you have to identify the right size to how your application is running. So if you have a cluster and have 5 to 6 databases, this may be a good fit. If you have just one database, and then one database, but it is still critical enough, but you do not want high availability, this is a good case. Obviously this is an expensive approach, but this is an economical approach. So Oracle gives you options to which one you need to take up. So base database service, like I said, is fixed shape. The standard, this presentation will be available even after the event. So I'll be putting it in my dev.to, so you can download this. So it's a fixed shape. You can have, it says 2 node rack here, but last week Oracle decommissioned this, but it is not 2 node anymore. So it is only a single node anywhere.
Yeah, that's I can give an answer to that. So
Yeah.
our recommendation is for the customers who want rack, they should use exascale. That's
Yeah.
the reason behind it.
Yeah, correct. But in base database service, I think 2 node rack is no longer
It's
available.
very new. This may be a few weeks before. All the newer, and if you you want to provision today in base PP, you cannot do.
Yeah, but whatever is provisioned, it is still available.
That's primarily a business decision.
Yes, correct. So, so basically, when you say Exadata storage systems are like, and the actual difference between, in terms of storage between base database servers and Exadata storages, Exadata storage has high redundancy, whereas base database storage has external redundancy. When you say external redundancy, you have a huge pool of storage, but somehow Oracle guarantees that the hardware level guarantee is your storage is safe. But here it says high redundancy, which means if you need 1 TB of storage, you have to allocate 3 TB of storage. But here if you allocate 1 TB, Oracle takes care of its own mirroring, but it is not as reliant on this. So that is the difference, where you have an environment where Oracle takes care of redundancy within the stack, but there you have a cloud provided redundancy. So these are the technical know-hows that cloud administrators must identify before provisioning the environments. Now, different shapes and sizes, and these have, I would say, limited shapes. Like for example, here the max storage that you can have here is 80 TB. Here the max storage I can have is about, I can even go to 512 TB in storage. 512 TB in a particular rack, or even more. In sometimes, the more storage nodes I add, the more storage I get. So I need to you can have a half node Exadata, half rack Exadata, or a full rack Exadata based on how many nodes you want to have. So earlier in on-prem, so what happens is that now whether you require or not, at a minimum you will need to take a quarter rack Exadata. But in today's world, you don't need to take. I don't need to take a quarter rack. I can take even a 1/8 rack, because the cloud is providing me that flexibility, so that you can reinvest that money, whatever, into your better applications. So storage and performance, obviously this is definitely much better than that one. But the difference to identify is like mission critical applications with high availability will always prefer Exadata. Applications which can run in silos but still need a decent amount of compute power to work, you can still use them. So then licensing model, high availability is available only here, it is not available here. For earlier, Oracle used to provide it, but that was very difficult for Oracle to maintain high availability in both the classes of servers. So Oracle has given high availability only in Exadata here. So licensing model, it is just pay as you use. So the more storage you use, the more CPUs you use, Oracle will calculate the licenses. So there is something called as an OCI cost calculator. So anyone who wants to compute anything on OCI, you can use the calculator that is available for free. So again, which one to use? It's your application needs to decide which one to use. So you need to decide how mission critical is my application, and then decide based on that. So these are generic reference notes. So the hands-on learning is what I had showcased earlier. So we'll take some questions, or what we can do is we'll just go for a break, and Suraj was the guest speaker. We'll go for a break, and we can, any questions that we have, we can offline discuss on it as well. So I think we have to wind up here by 6:15. I think we have about 15-20 minutes time. We can have a good break, snacks upstairs, and we can discuss that you want. Even if you want any questions ad hoc also, you can ask me. So we would like to have these events more regularly, but time constraints and my team's availability is dependent on these events. So coming back to questions, if you have any questions, like anything that you would like to have on Linux databases, OCI, let me know. So these kind of events are like, this creates an awareness of how the current cloud stack in Oracle is. Obviously, similar events in AWS and Azure are happening in multiple places, but we focus more on OCI here from Nabhaas. So can we all take a break then? We'll just understand, get to know each other. Any questions we can handle offline as well. So break is upstairs, so you can take the lift. So snacks is available there.
Who is that?